Hello students, I am Latarani HM, Assistant Professor of Mathematics. Today we discuss about the topic Cauchy's root test in the paper Infinite series. In the previous classes we learnt about so many tests, comparison test, D'Alembert's ratio test and also Rabi's test. By using the test, we find out the nature of the series. The one more test is there, that is Cauchy's root test. In this class, we discuss about the statement and proof and also some examples on Cauchy's root test. Cauchy's root test. State and prove Cauchy's root test. What is the statement? Let summation of un be a series of positive terms such that limit n tends to infinity un to the power of 1 by n is equal to L. Then if L less than 1, the given series is convergent. If L greater than 1, the given series is divergent. And if L is equal to 1, the test fails. Proof. By the data, what is the given here? Limit n tends to infinity, un to the power of 1 by n is equal to L. Consider this data. Here L is a finite. And apply the definition of the limit to this function. Let epsilon be any positive real number, then there exists a positive integer m such that, according to definition of the limit n tends to infinity un to the power of 1 by n is equal to L can be written as mod of un to the power of 1 by n minus L less than epsilon for all n greater than or equal to m. Now expand the mod. When we expand this mod, we get like that L minus epsilon less than un to the power of 1 by n is less than L plus epsilon, where n greater than or equal to m. Now raise the power n on both sides here. Then we get L minus epsilon to the power of n is less than un to the power of n by n get cancelled. We get 1 less than L plus epsilon to the power of n. Call it as equation number 1. Now consider the cases. Here we have the two cases. One is L less than 1. Another one is L greater than 1. Consider the first case, L less than 1. If L less than 1, we can choose epsilon such that L plus epsilon is less than 1. Put L plus epsilon is in a small r. R is less than 1. Then substitute in equation 1. What is L plus epsilon? L plus epsilon to the power of n. That is nothing but r to the power of n. Now consider this inequality. Un less than L plus epsilon to the power of n, that is un is less than r to the power of n. Apply the summation on both sides. We get summation un is less than summation r to the power of n. This represent. In the previous classes, we already discussed about the geometrical test and also a P test. P test means our order test. P series test or order test is in the form of 1 over n raised to P form. Geometrical series test means it is in the form of r raised to n form. Now, this represents the geometrical series form. Here, this is the geometrical series with common ratio. What is r? R is less than 1. Therefore, summation r to the power of n is a convergent. But summation of un less than summation of r to the power of n. But summation of r to the power of n is convergent. Hence, summation of un is also a convergent according to comparison test. Hence, we conclude that the given series summation of un is convergent if L less than 1. Now consider the another case. Another case is L is greater than 1. If L greater than 1, choose epsilon such that L minus epsilon is greater than 1. Put L minus epsilon is a capital R. because in the previous case L plus epsilon can be taken as a smaller. To avoid the confusions, take L minus epsilon as a capital R. Now substitute in equation 1, we get L minus epsilon to the power of n is less than un. This is there in the equation number 1. Now L minus epsilon is a capital R. R to the power of n is less than un. Apply summation on both sides. We get summation R to the power of n is less than summation un. According to geometrical series, here R is a common ratio. Its value is greater than 1. According to geometrical series, if R greater than 1, the given series is a divergent. Therefore, summation of R to the power of n is divergent. Hence, summation of un is also a divergent because summation of R to the power of n is less than summation of un. This one is convergent. Therefore, un is also a divergent according to comparison test. Hence, we conclude that summation of un is divergent if L greater than 1. This is the proof of the Cauchy's root test. Now we move on to the examples. First example is discuss the convergence of the series summation 1 by log n to the power of n. Consider un is equal to 1 by log n to the power of n. See here, Cauchy's root test is applicable for the given problem is in the form of, the given series is in the form of f of n to the power of g of n form. Here power is in a n, therefore we are applying the Cauchy's root test. Consider limit n tends to infinity, un to the power of 1 by n is equal to limit n tends to infinity, un is nothing but 1 by log n to the power of n. n get cancelled, we get 1 by log n. Now apply the limit n tends to infinity, 1 by log infinity is a 1 by infinity which is equal to 0. Here 0 is less than 1. Therefore, by Cauchy's root test, the given series is convergent. Now consider another problem. Discuss the nature of the series or convergence of the series 1 cube by 3 plus 2 cube by 3 square plus 3 cube by 3 to the power of 3 plus 4 cube by 3 to the power of 4 plus so on. Here 3 cube is get cancelled, we get the 1 value also. Suppose in the problem they given 1, you have to write like that. Answer. Consider summation of un as the given series. Here series given values in the form of series form. So write the nth term. Numerator by denominator function is there. So first write the nth term for the numerator. What is the numerator elements here? 1 cube, 2 cube, 3 cube, 4 cube. Therefore, nth term is n cube. Similarly, the nth element of the denominator is 3, 3 square, 3 cube, 3 to the power of 4 plus so on. That nth term is 3 to the power of n. Now apply the Cauchy's root test for the given nth term. Limit n tends to infinity, un to the power of 1 by n is equal to limit n tends to infinity, n cube divided by 3 to the power of n, 1 by n. Here 3 to the power of n, 1 by n get cancelled, we get 3. Then n cube to the power of 1 by n, rearrange that one, we get n to the power of 1 by n to the power of 3. 1 by 3 is in a constant, take outside from the limit, remaining is limit n tends to infinity of n to the power of 1 by n. It is in a standard limiting value. What is the value? This value is 1. So 1 cube is 1. Get 1 by 3. 1 by 3 is the solution of limit n tends to infinity un to the power of 1 by n, which is less than 1. Therefore, according to Cauchy's root test, the given series is convergent. Next, move on to the third problem. Discuss the convergence of the series summation 1 plus nx to the power of n whole divided by n to the power of n. Answer. Consider un is equal to 1 plus nx to the power of n divided by n to the power of n. Here it is in the form of f of n to the power of g of n form. Apply the Cauchy's root test. Consider limit n tends to infinity un to the power of 1 by n is equal to limit n tends to infinity 1 plus nx to the power of n divided by n to the power of n to the power of whole to the power of 1 by n. Here in the numerator and denominator we have power n is a common, take outside and it will be cancelled. Remaining is 1 plus nx divided by n. That is nothing but 1 by n plus n get cancelled plus x. Now apply the limit for this function. Limit 1 by n tends to infinity, 1 by n is nothing but 1 by infinity, that is its value is a 0 plus n cancel x. It is a free from the n value, therefore we write x itself. X plus 0 gives x. Here x is a variable, it may be less than 1 or greater than 1 or equal to 1. According to Cauchy's root test, if x less than 1, given series is convergent. If x greater than 1, given series is divergent. And if x is equal to 1, the given series means the test will be fails. If test fails, when Cauchy's root test fails, then we are applying the two method. One is ordered test. Ordered test means it is nothing but the 1 over n raised to p form test or fundamental test. Put x is equal to 1, then we get un is equal to 1 plus n to the power of n divided by n to the power of n. That is un is equal to 1 plus n divided by n to the power of n. Apply the limit on both sides. Limit n tends to infinity un is equal to limit n tends to infinity 1 plus n by n to the power of n, that can be written as 1 by n plus 1 to the power of n. This is in a standard limiting value. 1 plus 1 by n to the power of n is nothing but e, where e is nothing but the 2.7. 2.7 is not equal to 0. This is called as a fundamental test. Fundamental test means limit n tends to infinity of un is equal to 0, given series is convergent. If it is not equal to 0, then the given series should be a divergent. Here we have not equal to 0, hence the given series is divergent if x is equal to 1. Hence we conclude that the given series is convergent if x less than 1 and divergent x greater than or equal to 1. This is the Cauchy's root test. Thank you.